Hey everyone, and welcome to today's Explainer. I am literally so excited you're joining me today because we are unpacking a truly massive set of mid-year Google Cloud updates from July 2026. Now, what we're looking at here, it's not just some random assortment of new features. When you step back and put all these updates together, they collectively form a highly sophisticated, completely end-to-end enterprise AI stack. So if you've been sitting there trying to figure out how to jump from, basic AI experiments to actually deploying secure agentic workflows at scale, well, this Explainer is exactly what you need. To really get why all of this matters right this second, you just need to hear this one striking statistic from Google Cloud's State of AI Infrastructure Report. 83%. Yeah, 83% of organizations are saying they absolutely need infrastructure upgrades just to support agentic AI systems. We're talking about incredibly unique demands here, persistent, stateful, long-running processes that traditional architectures, honestly, they just weren't built for. So the takeaway here is that the shift to agentic AI, it's not just a software update, it's a fundamental infrastructure challenge. And that is exactly the problem these new Google Cloud updates are designed to solve. So, to make sense of all these new capabilities, we're going to break this down into three main layers. First, we've got the Builder's Toolkit. Then we'll look at powering AI with data. And finally, we'll wrap up with secure and governed execution. Let's get right into it. Layer 1, the Builder's Toolkit. Let's dive into this top layer and check out the new tools developers are using to actually construct these next-gen agentic systems. Okay, so model choice on the Gemini Enterprise Agent platform is just exploding right now. First, check out the new media models. We've got Nano Banana 2 Lite, which is also known as Gemini 3.1 Flashlight Image, and this thing can pump out high-quality visuals in literally 4 seconds, complete with improved world knowledge and text localization. Right alongside it is Gemini Omni Flash, which is now in public preview. This model is an absolute beast for conversational video generation and editing, and it's remarkably cheap at just 10 cents per second of video output. Oh, and both of these integrate content credentials and Synth ID watermarking right out of the box by default. But actually, what if you're scaling Anthropic models instead? Well, Google Cloud now gives you fully managed infrastructure for Claude models right through the agent platform's model garden. This is huge because it means you can invoke Claude using standard REST and JSON endpoints, but you completely inherit all of Google Cloud's native security, like identity and access management, VPC service controls, and logging. Plus, you get 3 routing options: global for automatic failover, regional if you have strict data residency needs, and multi-region for localized resilience. Now, if you really want to see agentic AI in action, you have to look at Alpha Evolve, which just hit general availability. This is a Gemini-powered coding agent built specifically to optimize advanced algorithms. So instead of just writing a basic script, Alpha Evolve uses an agentic harness to systematically explore massive search spaces and generate highly optimized code. It works in 4 simple steps. First, you define a baseline algorithm, basically pointing the tool at the code you want it to fix up. Second, you establish your deterministic scoring metrics, like a client-side evaluation script that checks for correctness and performance. Third, you run the agentic harness. It repeatedly mutates, compiles, tests, and scores the code, feeding those metrics right back to the API. And finally, step 4, you apply that perfectly optimized algorithm into your production infrastructure. It's basically AI engineering better AI. How wild is that? All right, moving on to layer 2, powering AI with data. Because we have our models and agents, but to drive actual real-world business value, we have to connect them to your enterprise data. And this brings us to a totally massive update for the data practitioners out there: conversational analytics in BigQuery. You can now author specialized Gemini-powered agents that are fully grounded in your own data, meaning you can query your data warehouses using just pure natural language. But wait, it gets better. It's not just limited to native BigQuery tables. These agents can securely reach across clouds to query Apache Iceberg tables, Databricks Unity, AWS Glue, SAP, and even Salesforce. You can run built-in AI functions to forecast trends or spot anomalies across both relational and unstructured data. You can even deploy these agents to autonomously run multi-step investigations on a set schedule. It's a real game changer. But of course, with agents now running around querying your data, a new problem pops up. How do you actually measure if they're any good at retrieving the right datasets? Enter Discovery Bench. This framework is absolutely crucial because traditional pass/fail benchmarks are frankly subjective. They completely fail to show where an AI's capability actually hits a wall. So Discovery Bench changes the game by treating query difficulty as a measured scientific quantity. It does this by adding or removing steering terms based on their information theoretic informative power, which is a fancy way of saying their surprisal. By dynamically tweaking this surprisal level, data teams can systematically test exactly how well their AI data agents retrieve datasets across varying levels of context. And for those of you looking to run foundation models directly inside your databases, the core AI functions for AlloyDB have officially reached general availability. This includes stuff like text generation, ranking, conditional processing, and forecasting. But the real so what here is their new smart batching capability. Historically, doing row-by-row model calls from a database was painfully slow and really expensive. Smart batching completely fixes this by automatically calculating the optimal batch size and only sending boilerplate instructions once per batch. This dramatically slashes both latency and costs, making large-scale AI database operations super efficient. Now we've reached the final and honestly most critical layer, Layer 3, secure and governed execution. Because without this, everything we just talked about totally falls apart. This next one is arguably one of the most highly anticipated updates we've seen. Cloud Run sandboxes are officially in public preview. Look, when you're building agent workloads, whether that's LLM code interpreters, headless web browsers, whatever, if it's executing user-submitted scripts, you are inherently dealing with untrusted code. Cloud Run sandboxes give you a native, completely isolated runtime environment right inside your existing Cloud Run instances. In literally milliseconds, you can spin up a sandbox to execute that sketchy AI-generated code or untrusted binary. This sandbox has absolutely zero access to your application secrets, and its egress is entirely locked down by default, meaning you can run risky tasks safely without ever putting your host application or cloud credentials in danger. Now, as organizations start really scaling up their use of Anthropic's agentic coding tool Claude Code, a huge operational headache has been managing per-developer cloud credentials. I mean, one developer pointing Claude Code at Vertex AI is fine, but 1,000? That's a massive security nightmare. Nobody wants API keys just floating around on local machines. So Google Cloud introduced this self-hosted Claude Apps Gateway. By routing your developer workstations through this gateway, it manages identity authentication via an OIDC provider like Google Workspace. That means no API keys are ever exposed locally. Plus, the gateway enforces server-side role-based access control, puts hard caps on token spend, and centralizes all that usage telemetry right into cloud monitoring. It totally removes the friction of managing access for large teams. Over on the Kubernetes side, we've got that classic tug-of-war happening. Developers are trying to move fast, rapidly deploying AI workloads like VLLM, vector databases, and LangChain agents, usually without formally registering them. Meanwhile, security teams are desperate for runtime visibility into these clusters, and SREs just want to keep the cluster stable. The brilliant answer to this is K8's AI Bomb. It's a lightweight, open-source, unprivileged Kubernetes controller. It runs directly at runtime, continuously monitoring cluster resources to identify running AI stacks. And the best part, it automatically generates machine learning bills of materials, ML bombs, without developers having to modify their pods at all, and with zero impact on cluster stability. Security gets the exact visibility they need, and devs get to keep moving fast. Win-win. And to round out the infrastructure foundation, we've got a massive slate of hardware-level confidential computing updates. Let's just fire through these real quick to see how the very silicon of this stack is being locked down. We've got the confidential G4 machine series in preview, open-source prompt encryption SDKs, and support for Apple Private Cloud Compute. On top of all that, Google Cloud rolled out Intel TDX on the new network and storage-optimized C4 machine series, general availability for live migration, Intel Trust Authority integration, and confidential space support for NVIDIA Hopper GPUs. They are making absolutely sure that the fundamental compute layer is entirely secure, so your most sensitive IP never ever leaks. And honestly, this comprehensive, layered approach, starting from the Builder's Toolkit all the way down to those confidential GPUs, is exactly why Google Cloud is taking a massive victory lap right now. They were just named a leader in the IDC MarketScape for worldwide foundation model software, and a leader in the inaugural Gartner Magic Quadrant for AI infrastructure, actually positioned highest for ability to execute and furthest for completeness of vision. The market is very clearly validating this whole end-to-end stack approach. Which brings us to a close and circles us right back to where we started. We saw earlier that 83% of organizations know they need an infrastructure upgrade to handle the future of AI. So the question I want to leave you with today is this. Is your current infrastructure truly ready to support the unique, persistent, and stateful demands of these agentic AI systems? With tools like Alpha Evolve, Cloud Run sandboxes, and BigQuery conversational analytics now at your fingertips, the technology is completely here. The next step is building the foundation to support it. Thank you so much for joining me for this explainer, and I highly encourage you to go take a hard look at how your own stack measures up.